Square wave and modified square wave inverters produce non-sinusoidal waveforms, which can create harmonic distortions in the electrical circuit. This can interfere with the proper operation of smoke detectors designed for sinusoidal waves. The non-sinusoidal waveforms can cause fluctuations in voltage and current, which can disrupt the sensitive electronics of smoke detectors. The harmonics produced by these inverters can resonate with the detector's natural frequency, causing false alarms or reduced sensitivity. Firstly, opt for inverters that produce true sine wave output, which is compatible with most smoke detectors. Secondly, consult with the manufacturers of your smoke detectors and inverter systems to confirm compatibility. They may provide specific guidelines or recommendations. Thirdly, ensure that your smoke detectors have battery backups in case the inverter fails or power is lost. Fourthly, consider low-voltage smoke detectors designed for solar photovoltaic systems or other alternative power sources. Fifthly, regularly test your smoke detectors, especially if they are connected to inverters, to ensure they are functioning properly. Some manufacturers offer smoke detectors specifically designed for use with modified sine wave inverters. If your current smoke detectors are incompatible with your inverter system, consider replacing them with models designed for that purpose. Always prioritize fire safety and follow the manufacturer's instructions meticulously. The electrical characteristics of sine wave, square wave, and modified sine wave inverters significantly impact their suitability for use with smoke detectors. A pure sine wave inverter produces a waveform that closely resembles the sinusoidal voltage supplied by the utility grid. This smooth, consistent waveform ensures stable and reliable operation of sensitive electronic devices like smoke detectors. The voltage and frequency are tightly regulated, minimizing the risk of interference or damage. Square wave inverters, on the other hand, generate a waveform that abruptly switches between positive and negative voltage levels, creating a rectangular shape. This sharp transition introduces significant harmonic distortion into the electrical system. These harmonics can interfere with the internal circuitry of smoke detectors, leading to false alarms, reduced sensitivity, or even complete failure. Modified sine wave inverters attempt to approximate a sine wave by using a stepped waveform. While they are an improvement over square wave inverters, they still contain significant harmonic distortion compared to pure sine wave inverters. The stepped waveform can cause similar issues with smoke detectors as square wave inverters, although potentially to a lesser extent. The total harmonic distortion, often abbreviated THD, is a measure of the amount of harmonic content present in a waveform. Pure sine wave inverters typically have a THD of less than 3%, while square wave and modified sine wave inverters can have THD levels as high as 40% or more. Smoke detectors are designed to operate within specific voltage and frequency ranges. Deviations from these ranges can affect their performance. Square wave and modified sine wave inverters can produce voltage spikes and frequency variations that exceed the tolerance of smoke detectors, leading to malfunctions. Many smoke detectors rely on zero crossing detection to synchronize their internal timing circuits. Zero crossing refers to the point where the voltage waveform crosses the zero voltage axis. The sharp transitions in square wave and modified sine wave inverters can create multiple zero crossing points, which can disrupt the timing circuits and cause erratic behavior. Smoke detectors often incorporate filters to remove unwanted noise and interference from the power supply. However, these filters may not be effective at blocking the high-frequency harmonics produced by square wave and modified sine wave inverters. These harmonics can saturate the filters, reducing their ability to suppress noise and allowing interference to reach the detector's sensitive electronics. The impedance of the inverter and the smoke detector can also play a role in compatibility. If the impedance of the inverter does not match the impedance of the smoke detector, it can cause voltage reflections and standing waves in the electrical system. These reflections can amplify harmonic distortion and further disrupt the operation of the smoke detector. When selecting an inverter for use with smoke detectors, it is essential to consider the power requirements of the detectors. The inverter must be able to provide sufficient power to operate all connected smoke detectors simultaneously. It is also important to ensure that the inverter has adequate surge capacity to handle the inrush current that occurs when the smoke detectors are initially powered on. Surge capacity refers to the inverter's ability to provide a brief burst of power that exceeds its continuous power rating. Some smoke detectors are equipped with transient voltage surge suppression, often abbreviated TVSS, circuitry to protect them from voltage spikes. However, these TVSS circuits may not be effective at suppressing the high-frequency harmonics produced by square wave and modified sine wave inverters. When installing smoke detectors with inverters, it is important to follow all applicable electrical codes and safety standards. This includes ensuring that the wiring is properly sized and grounded and that the inverter is installed in a well-ventilated location. Regular maintenance and testing of both the smoke detectors and the inverter are essential to ensure their continued proper operation. This includes checking the battery backups in the smoke detectors and inspecting the inverter for any signs of damage or overheating. In some cases, it may be necessary to install a line conditioner or filter between the inverter and the smoke detectors to reduce harmonic distortion and improve compatibility. A line conditioner is a device that filters and regulates the voltage and frequency of the power supply. It can help to smooth out the waveform and reduce the amount of noise and interference that reaches the smoke detectors. When choosing a line conditioner, it is important to select one that is specifically designed for use with square wave or modified sine wave inverters. Some line conditioners may not be effective at filtering the high-frequency harmonics produced by these inverters. An alternative to using a line conditioner is to install a dedicated pure sine wave inverter for the smoke detectors. This ensures that the smoke detectors receive a clean, stable power supply that is free from harmonic distortion. The cost of a dedicated pure sine wave inverter may be higher than the cost of a line conditioner, but it can provide a more reliable solution in the long run. In addition to voltage compatibility, it is also important to consider the current requirements of the smoke detectors. The inverter must be able to provide sufficient current to operate all connected smoke detectors simultaneously. It is also important to ensure that the wiring is properly sized to handle the current load. Undersized wiring can overheat and create a fire hazard. When installing smoke detectors with inverters, it is important to label the electrical panel to indicate that the smoke detectors are powered by an inverter. This can help to prevent accidental disconnection of the inverter during maintenance or repairs. It is also important to inform any electricians or other service personnel who may be working on the electrical system that the smoke detectors are powered by an inverter. The use of battery-operated smoke detectors can eliminate the compatibility issues associated with inverters. Battery-operated smoke detectors do not require a connection to the electrical system, so they are not affected by the waveform or harmonic distortion produced by inverters. However, it is important to ensure that the batteries in battery-operated smoke detectors are replaced regularly to ensure their continued proper operation. Some smoke detectors are equipped with wireless interconnectivity, which allows them to communicate with each other. If one smoke detector detects smoke, it will send a signal to the other smoke detectors, causing them to sound an alarm as well. Wireless interconnectivity can be a valuable safety feature, especially in larger homes or buildings. When using wireless interconnected smoke detectors with inverters, it is important to ensure that the wireless signals are not interfered with by the inverter. Some inverters can generate electromagnetic interference, often abbreviated EMI, which can disrupt wireless communication. If EMI is a concern, it may be necessary to shield the inverter or relocate the smoke detectors to minimize interference. In some cases, it may be necessary to consult with an electrician or fire safety expert to determine the best solution for your specific situation. They can assess your electrical system and provide recommendations on the most appropriate smoke detectors and inverters to use. They can also help to ensure that the smoke detectors are properly installed and maintained. Remember that smoke detectors are a critical safety device that can save lives. It is essential to ensure that they are functioning properly and that they are compatible with your electrical system. Always prioritize safety and follow the manufacturer's instructions carefully. The National Fire Protection Association, often abbreviated NFPA, provides comprehensive standards and guidelines for fire safety, including the installation and maintenance of smoke detectors. NFPA 72 is the National Fire Alarm and Signaling Code, which covers the requirements for fire alarm systems, including smoke detectors. It is important to be familiar with NFPA 72 and other relevant fire safety codes and standards. Local building codes may also have specific requirements for smoke detectors. It is important to check with your local building department to ensure that your smoke detectors comply with all applicable codes. Carbon monoxide detectors are another important safety device that should be installed in every home. Carbon monoxide is a colorless, odorless gas that can be deadly. Carbon monoxide detectors can alert you to the presence of carbon monoxide in your home, giving you time to evacuate and seek medical attention. Carbon monoxide detectors should be installed on every level of your home, including near sleeping areas. They should be tested regularly and their batteries should be replaced at least once a year. Combination smoke and carbon monoxide detectors are also available. These detectors combine the functions of both smoke detectors and carbon monoxide detectors into a single device. Combination detectors can be a convenient and cost-effective way to protect your home from both fire and carbon monoxide poisoning. When installing smoke detectors, it is important to choose the right location. Smoke detectors should be installed on the ceiling or high on the wall as smoke rises. They should be located in hallways, near sleeping areas, and on every level of your home. Avoid installing smoke detectors in kitchens or bathrooms, as steam and cooking fumes can trigger false alarms. It is also important to keep smoke detectors clean. Dust and debris can accumulate on the detectors, reducing their sensitivity. Smoke detectors should be cleaned regularly with a vacuum cleaner or soft brush. Never paint smoke detectors, as this can block the vents and prevent them from detecting smoke. Smoke detectors should be tested at least once a month. To test a smoke detector, press the test button on the detector. The detector should sound a loud, clear alarm. If the detector does not sound an alarm, replace the batteries or replace the detector. Smoke detectors should be replaced every 10 years. Over time, the sensors in smoke detectors can become less sensitive, making them less effective at detecting smoke. Replacing smoke detectors every 10 years ensures that they will continue to provide reliable protection. When replacing smoke detectors, it is important to dispose of the old detectors properly. Some smoke detectors contain radioactive materials which can be harmful to the environment. Check with your local waste management agency for instructions on how to dispose of smoke detectors properly. Educating your family about fire safety is also important. Make sure everyone in your family knows what to do in case of a fire. Develop a fire escape plan and practice it regularly. Teach children how to call for help and how to stop, drop, and roll if their clothes catch fire. By taking these steps, you can help to protect your family from the dangers of fire. Remember to always prioritize fire safety and to follow the manufacturer's instructions carefully.